Determine the effective focal length of the combination of the two lenses in exercise 9.10 if they are placed 8 cm apart. So D is equal to 8 cm with their principal axis coincident. Does the answer depend on which side of the combination of parallel light is incident? Is the notion of effective focal length of the system useful at all? So here earlier we have f1 is equal to 30 centimeter and f2 is equal to minus 20 centimeter, right? Now u1, because of object we have at infinite distance, u1 is equal to infinite, we have to find v1 for that. So 1 upon f1 is equal to 1 upon here we are talking about that yes, so we have used lenses, so 1 upon v1 minus 1 upon u1, so 1 upon v1 subject is equal to 1 upon f1 plus 1 upon u1, so is equal to 1 upon f1, so that is 1 upon 30, u1 that is infinite, so plus 1 upon infinite, so v1 is equal to 30, right? So I have to write here 30 centimeter. Now we have to find u2. u2 is equal to 30 minus d, because d separation is also given. Now for second lens, this is object distance, so 30 minus d, so 8 is there, so 30 minus 8 is 22 centimeter. Now we have to find v2, so 1 upon f, direct I am writing that formula, that 1 upon v2 is equal to 1 upon f2 plus 1 upon u2. So by putting all the values is equal to 1 upon f2 is 1 upon minus 20, now u2 is 1 upon 22, so is equal to 1 upon 20, right, 0.05, and 1 upon 22 minus 0.05, so that is minus 4.54 into 10 raised to minus 3. Now 1 upon reciprocal of that, that is minus 220. So here u2 is equal to minus 220 centimeter, that is our u2. Now that is our v2, by mistake I have written, that is our v2 we found, right? So v2 is equal to minus 220 centimeter. Now here 220 minus that d by 2, so d is 8, right? 8 by 2 is 4, so that is 216 centimeter. So that is the distance, right? Now that distance is 216 centimeter. Now see for next one, now u2 is equal to infinite distance and v2 that we have to find, right? So formula for that is 1 upon v2 is equal to 1 upon f2 plus 1 upon u2. So f2 is minus 20, so v2 is equal to minus 20. So now we have to find u1 is equal to minus 20 plus d. So u1, d is 8 that we know, so minus 28 centimeter will be there. Now we have to find v1 also, so 1 upon v1 is equal to 1 upon f1 plus 1 upon u1, right? So by putting values 1 upon f1 that is 30, so 1 upon 30, right, and 1 upon 28, so 1 upon 28, right? So that answer is 1 upon 28, that is negative, so negative of that answer plus 0.333, right? So 0.29, so 1 upon reciprocal of that, so 3.36, right? So that we see, I have to write here all the values. 1 upon f1 is 30 and u1 is minus 1 upon 28, right? So v1 we found that is equal to v1 is equal to 420 centimeter. So 420 minus d by 2 again, and d by 2 is 4, so that is 416 centimeter. So this is for the system that is effective V1 U1, right? Now second question, an object 1.5 centimeter in size is placed on the side of the convex lens in the arrangement A above. The distance between the object and the convex lens is 40 centimeter. Determine the magnification produced by the two lens system and the size of the image. So here H1 is given 1.5, earlier U1 is equal to minus 40 centimeter, and mod of that value is plus, so 40 centimeter. V1 that we need to find, so 1 upon V1 is equal to 1 upon F1 plus 1 upon U1, so is equal to F1, right? Earlier we have F1 and that is 30, so 1 upon 30 plus 1 upon 40. So V1 cross multiplication, so 40 into 30 upon 70, so that is 17.14, so 17.14, that is V1 centimeter. Now magnification to find, that is V1 upon U1, so 17.14 upon that value, that is 40, so upon 40, that magnification is 0.42. Here by mistakenly I have written positive, but here it is actually negative. So V1 will be 120 centimeter if you do this solution, right? So now magnification formula is V1 upon U1, that is 120 upon U1, that is 40. So here for magnification we have to use mod value. So 0 0 cancelled out, so we are left with 3. Now U2 is equal to V1 minus D, and that is 120 minus D, that is 112. Now we have to find V2. So 1 upon V2, again 1 upon F2 plus 1 upon U2. So V2 will come, that is 24 minus 24.34 centimeter. Now magnification that we have to find, so magnification M is equal to V2 upon U2, mod value of that. So here 24.34 upon U2, U2 is 112, so 112 is equal to now 24 upon 112, so that is 0.217, right? So now this is our M dash. Earlier we found M, that is 3, right? So now multiplication of these two, M dash into M, we will get combined magnifying power of this whole system. So see, earlier M we found is 3 and M dash we found is 0.2. So M into M dash, that is total magnification. So 0.6 is the answer, and 0.6 we know that is H2 upon H1. So H1 we want to find, so H1 is equal to, earlier we wrote that 1.5 centimeters. So H2 we have to find, so H2 subject 0.6 into 1.5, so that will be here 0.6 into 1.5, that is 0.9 centimeter. So that is the height of H2.